Today I'm going to talk about threads. Threads are like mini programs running inside a bigger program. They're they're like workers. They work on different tasks at the same time. So like oftentimes you'll have functions in a program and you can create threads that each one works on a different function at the same time. So it's kind of like a team. So threads allow a program to do multiple things at once, making it faster and more efficient. In my program, um, is mostly about Viginere Cipher, and that's sort of like a Caesar cipher, except you have to have a keyword instead of just rotating among the alphabet. You have to have a keyword, and then you rotate the keyword to. I'll go over the code. But it's similar to a Caesar cipher. So I have different functions I use, and I have like an input thread, an encryption thread, a new line, replacer thread, a decryption thread, and an output thread. Um, so sometimes a designer has to choose between threads and processes, like with the fork, creating a whole new process. Um, Using threads is different from creating separate processes. Separate processes are like running multiple programs at once, whereas threads share the same memory space. So when you're using the fork command, this command, um, you're creating new memory and you're creating multiple programs that are running. So that's creating memory is not additional memory is not necessarily a good thing. Threads they share the same memory, so and they can get complicated communicating too when you're using a bunch of processes with their own memory. So in this program, using threads has faster communication. They're able to share data quickly because they're using the same memory space. Um, Creating and managing threads is usually faster and uses fewer resources than creating separate processes. So threads improve the performance of a program by doing a bunch of tasks at the same time. So let me go over the code. So you got to use I use the time right there for the time library for the random. So to generate a key. So basically, like I said, it has multiple. I have 5 threads. I have an input thread, an encryption thread, and a new line replacer thread, a decryption thread, and an output thread. So this program handles all that by using threads. So I create a buffer structure that holds the data. It counts. It has a count, as a stop flag, um, and synchronizations. I mean, threads. When you have multiple threads, you have synchronization, like mutex and condition variables, so that so when you're dealing with the same memory space, you only want one thread at a time to work with the memory space. So a mutex locks the memory space for one thread, and then you can unlock them. And then a condition variable, it allows threads to signal to each other that a memory space is available. So so I create 4 buffers. And they have a mutex and a condition variable. So so the keyword, that's the keyword is the keyword character array plus 1, so it holds the null terminator. So this is going to be getting, this has an error handling function. So this is going to be a Viginere cipher. There's how you uh, spell this type of cipher. So you use a generate random keyword right there. That's a function for that. So I'm using that alphabet. It turns it to lowercase. And so I have, like, if you want to pause the video and read through that, how the Viginere cipher, the encryption works. There's the function for the Viginere to encrypt. So this gets the length of the text. This is going to be taking text from standard input. So you'll see I'll be typing in text. This gets the key length, the keyword. So it's going to take the text that's being typed in and the keyword that's generated. And then it's going to convert to capitals, or it's going to keep it capital or lowercase. This is like the algorithm when you're dealing with this type of encryption or decryption. You got to keep it within the alphabet, and you modulo it so it stays within, and you subtract a, that's the base, and then you add the base so that there's no negative numbers. So and Viginere Decrypts just does the same thing and does the same, basically the same type of algorithm. See to the to lower function. Difference between the encryption and decryption is it subtracts right here. Like the Caesar cipher. Caesar cipher, you encrypt by adding like 3 or something, and then you decrypt by subtracting 3, that type of thing. This is the input thread. This is the function, the input thread reads lines of input from the user and it stores them in a buffer. It stops reading when the user enters the 5 stars. And the pthread C library expects functions to return void pointer and take a void pointer. That's just the way it is in the pthread, is I'm using pthreads. See right there, pthread.h. So it's expecting that. So it's expecting just getting the lines of input, and then there's a mutex lock. Mutex lock on the first buffer. Then it starts looking for this so it could stop, and then it sets a buffer flag. Let me see the We'll go over this struct again, this buffer struct. This struct here has a count, and there's the stop. There's these. But that's why I created this struct. So it's going to have these attributes like count, stop, and buffer size. You could change the buffer size. I'm just doing small little, I'm just demonstrating threads. So, so when you have these attributes, so this is what copies input to the buffer. There's a pointer that's traversing, and then you update the count of the characters in the buffer, and then signal to other threads that new data is available in the buffer, and then unlock the mutex so the next thread can access that data, or another thread can access the data. And then there's the encryption thread. This function can be run by a thread to encrypt data from buffer 1. So the buffer that writes text from standard input is going to encrypt that data and store it in buffer 2. That's what this second thread does. So it's coordinating with mutex and condition variables. So it encrypts data from buffer 1 and stores it in buffer 2. That's what the second thread does. So that's why there needs to be a lock and a signal to let this thread know that it can perform its work. And so it locks the buffer also, and then it'll check if it's empty, and then it's waiting for the signal, checks for the stop flag, and the buffer 1 is empty. And so there's the buffer 2.stop attribute, and then it signals, and then it unlocks, then it exits the while loop to get to the to encrypt the data in the buffer with the keyword. Then it prints it out. Amount of characters in buffer 2, then it unlocks. So you reset the count to 0 for buffer 1, and it's done. And then you condition, you make the signal, and then you unlock. And these are part of the pthread library. That's what that is. That isn't. You see that code is not here in this code is because it's part of the pthread library. So in this one, this function just replaces the new line character. So at the end of these in the characters in buffer 2, there's a new line character. So it's getting replaced with spaces, and then copies the modified data to buffer 3. So it's checking for checks if buffer 2 is empty, and now it's waiting for a signal that buffer 2 that they can start their work with buffer 2. Sets the buffer 3 flag to that it's to stop. Signals the other threads that buffer 3 is they're finished with buffer 3. Another thread can work with buffer 3, and then it unlocks the mutex. Then it gets out of the loop, and then loops through each character in buffer 2, and then just replaces the new line character with the space. So, and then it copies the modified data. This is the modified data right there from buffer 2 to buffer 3. So this is the decryption thread. This function decrypts data from buffer 3 using the Viginere Cipher and stores the decrypted data in buffer 4. It runs continuously until it receives the signals to stop. So the same idea is happening here. It decrypts the buffer, decrypts the data in buffer 3 with the keyword, and then copies the decrypted data to buffer 4, updates the count of characters, and then it sends a signal that the new data is available in buffer 4, and then it unlocks the mutex. And now this is the output thread. This function writes data from buffer 4 to standard output. It runs continuously until it receives a signal to stop. So it's going to lock the mutex for buffer 4. So it's the only thread that's working on buffer 4. And so it's going to parse. It's going to keep checking if buffer 4 has less data than the output size and the stop flag is not set. It waits for a signal that enough data is available. It releases the mutex while waiting, and it requires it when it's signaled. So that's what pthread condition wait does. And so at the end, it writes the remaining data in buffer 4 to standard output. You'll see like that it written at the end. It resets the count. You notice that each of these buffers, the count resets, because that's important because it's dealing with memory spaces and you're parsing data. So you're trying to make sure you're getting every byte of data. So this is how you see the random number generator. You use the time library. This generates, that calls the generate random keyword, and then it'll print it to standard output. These are the thread IDs, and this is how you create threads, and this is the work. Each function is the work they're going to do. It's error handles, and the main function will wait for each one of these to finish before exiting. So that was the random generated keyword. So I'll put secrets. So it's taking the input, and then that's the Viginere Cipher, the encryption. That's decrypted. So passwords. So you can see how this works. Let's see. And then type this is what it's looking for when it's checking for the stop flag. And that's how that works. So that's my program in threads. Thank you.